Good day, everyone. On this session, I'll be re-recording yesterday's class because of some couple of challenges I was experiencing. So we managed to find solutions for them, and I hope on this video everything will go as planned. All right. So without any waste of time, I would like to start the session. Kindly inform students that they are free to come to the lab if they are available, or they can also still join online. I don't have a problem. The aim is to record the session more than anything. Okay? So as you know, even on the lab guide, the first thing first you do is to select new project. And one thing that I need to emphasize is that you can put stuff into wherever folder you want. Say for instance, you want to store in the customized folder with your details. You can click here under documents, create a new folder, and customize it according to your details. So this is actually the folder that you're going to submit once you are done, together with a screenshot of your program in case things go south. Right? And over here, you have to make sure that the type of PLC you are choosing is Codesys Control Win version 3, and Ladder Logic is the name of the program. And then every time when you come to the lab, because we uninstalled majority of the software, like the Codesys, we uninstalled it. So make sure that the computer you're sitting in, you install it. So you need to download it via the blackboard and install it afterwards, right? So when you're here, you click OK. All right. On the lab guide, this step I'm going to do is the last step. So I need to amend the lab guide to suit the very same, the first step that I want us to focus on. Okay, so you can either just go straight to Tools, Device Repository, or Device Repository. So this is a PLC, the device is a PLC, and we have under the Codesys Control version 3, we have the 3.5.15.40. This is the one that we want to work with. So you'd find that you have one that says 16, like on this case, it says 3.516. But if it's on version 3 and it says 16, please, you are required to uninstall the 16, the version 16 basically, or the service pack 16. So if you have it on you have only 15 here for version 3, you can leave it like that. Please note also, do not work with the 64-bit. Only work with this one, the version 3. And also make sure that it says Win and it doesn't say RTE or anything other than this one. Okay, then under fields also go to Ethernet adapter, make sure you only have the 15, and also under Modbus, you just open them like this, maybe 3 of them or maybe 4 of them. Yeah, just open a few and make it a point that you only left with 15. Otherwise, the app tends to override the other versions for the version 16. And you need to also make sure you come here. You can even start it if you want to, and go to About. Make sure that the 3.15.40 is also reflected there, to make sure that you are using the right version, right? So next up now, we are going to add a device. The device is under Ethernet, and I would like also to emphasize that it will change itself to home and building automation is still okay. Even if it does that, it's still okay. Then immediately after here, you can just click on the Ethernet on the side. So you can just jump on it. Then you are now able to now go to the Modbus. And every time you are able to see the 3.5, you are able to see the 15, service pack 15. And then you add the Modbus. Then you close. From here, you go at the top, you double click on your device, and you need to scan for the device. Scan for the device, then click OK. The device is now active. All right. So now under the PLC, this is where we're going to write our code. For testing purposes, we're just going to write it directly here. It's going to be I prefer caps lock everything. I add percent IX, let's say XI, nope, IX 0.0, full the colon, not semicolon, but the full colon, and then you write full, then semicolon. As I said, these are for your command. Maybe you can say this one I want it to be my start push button. Then you can just copy the whole thing, copy, click enter, and paste. So this is your I0. Now we are doing for the Q0. Our Q0 is going to be conveyor belt, CB conveyor belt. Maybe if there are plenty, it could be conveyor belt 1. You can even say conveyor belt 0 for argument's sake. Then maybe if you want to also, you can just align everything nicely and say over here, these are my inputs. You see, I used the forward strokes twice just to make sure that the PLC doesn't read the stuff. Then here over here, it's your outputs, right? Once you have it like this, you are free to come here, insert network. There's a reason why I always insert it. I would advise you to always insert it. Once we start to expand our program, you will see the reason why. If you didn't add them, you're going to experience some couple of problems. So I advise that you add them first. Okay, then you click on this insert. It's a normally open. You can just say I0. Then you click on this open space there on the block, and then you click on the insert coil. And then this is Q0, right? And then now you can just download and see if it will download. Okay, it has downloaded. Then you can also press play. After pressing play, your PLC and that they are active. All right, now let's go to our factory IO. Click on new file. No, don't say file. Let's add some components first. Today I'm going to test with a conveyor belt, a proper conveyor belt. As you can see, it's written down there that conveyor belt. Okay. I'm sure by now you appreciate that for me being able to do this, I'm using the right click instead of the left click. You are able to spin with the right click instead of the left click, right? So when I use a scroll, it goes forward and backward. Also, you can use your buttons as well. Right? And then there's a difference between the orbit camera and the fly camera. So this is a fly camera. It depicts how a drone would operate. So Those who have drones at home, they would know this. They will understand all these motions that this is doing. All right. And then when you now use the scroll for this one, it goes up and down. Then I use the right click, it will face properly. Then I go down. So if you want to see this perfect angle like this one, then when you go left, you go right if you want to, then forward. Okay? And now I want to place an item. I can place it in the front if I want to, and change to orbit in order for you to see if how far it is. If you want it to be close, you bring it close. Then I bring another component. When you press letter V, it now starts to move vertically. Then, okay, I see it's misbehaving. I'll put it on the side. And, okay, now it's agreeing to stick. Right. Now I'm going to put the push buttons. When I press letter V, they go up as well. Then I check them on the side profile, they are seated properly. So this one is on the air, as you can see there. Now it's seated properly, right? Then I can just take an item, maybe this crate, change angle in order for me to see where I want to place it, and V. But you can see it's not seated properly. I must shift it a little bit. And let me check how, yes, now it's centered, as you can see. Okay. Now, I want you to press either F4 or go to File, Drivers, and okay, I'm using split screen this here. Okay, then on this drop-down column, go down to your Modbus TCP IP client, click on it, and then these registers are our problem. So to remove these registers, you go to Configure and you scroll down. After configuring, you will see inputs there, register inputs. Please remove them, put 0 instead on the register inputs, even also on the register outputs, put 0. And after that, you click back. And now let's start by attaching our start button. Once it sits, let's attach our stop button. All right. And now let's connect. It is connected. Let's go back and let's test our program now. Now when I press, all right, it says indicator. Let's see what is wrong. You see, I placed on the stop button light instead of the conveyor belt. So I need to place a conveyor belt. Right? Then now when I press, my conveyor belt does move. Right? Bravo for that. Okay. Now here's a depiction of what is happening when I press. I'm just going to remove to the other screen so that you can see what happens on the program, because I'm using 2 screens. I can change the views. So now let me teach you something about PLC programming. Now, when you press and you let go, your machine stops. So now, this is not how in reality PLC works. It needs, when you press and let go, your workpiece needs to move until a certain condition is met. So before we can go to those conditions, let's start by creating a loop. When you come here, you'll also come there. It says insert contact parallel. That's how you now creating a parallel. You're going to loop, so you're going to write this over here. It says Q0. And we're going to install the program, and we click play, and we press the, see, now it's running. You see it's running forever, but it doesn't stop. It's gonna run until it falls, it falls over. It's gonna run until infinite. Even the sound says that it's running non-stop. So we don't want this. We want it to stop running when we press our stop button. All right. So now we need to put the stop button. We come here, copy this input, copy, and that's going to be input 1. And then we change it from 0.0 to 0.1. And this one becomes your stop dB. Then I'm going to put it as a normally closed at first. I want to teach you something. I1, okay? And you download, immediately download. Okay, so look at something now. When this one, I place it as a I1, automatically the PLC is running. Automatically the PLC is running. When I press that button, nothing is happening. The PLC continue to run. So it is not responding, all right? So the reason why it's not responding, it is because if you press F4 and you come, okay, I mean at this, let me edit stop button and let me start afresh so that you guys can see. Okay, I feel feeling that my view here is not conducive for me. Let me group this. This is how you group so that you can move stuff out of your way. Okay. So now let's see what's happening. So now here it's no longer connected. So when I press when I press the input, remove the input on the side. Look what's happening. It's not running. It's not running. But it says that the input one, it's actually connected. But when you look here, it's not connected. There's a saying that we have what is called a normally open and a normally closed. So this comes as a normally closed. And even if when you look here, it is activated. So now when it's activated, basically what it means is that when you press it, it will now it connect by pressing. So now we need to do opposite of this. Let's do it opposite. We invert. So I'm going to remove the negation there, and I install the very same program, and now we are blue there. We are blue, and nothing is running here. So what it means is that when I press, the system will connect. When I press the stop, the system's gonna stop. Let's view it. Now it's blue. I press start. Now the whole system is connected. And look at I0, it's not running. I0 is not connected. You only press it once and it will run. When I press the stop button, the system cuts the power. The stop button comes as a normally closed, therefore you use it as a normally open in order for you to be able to stop the process. Situation differs though. You will appreciate as I progresses. But for now, for the basic of starting and stopping, this is how you are using the normally closed stop button. And you will never find any stop button, whether the emergency stop button or the normal stop button, push button, you will never find it as a normally open in this program, right? So now our system is just running non-stop. As you can see, it just runs and it requires us to press the stop in order for it to stop. So what if we want it to stop at the end there without us pressing the stop button. So what is it that we need to do? We need to introduce a sensor. The sensor, we're going to place it. The sensors also come in different forms and shapes. We have sensors that are normally closed and sensors that are normally open. For this exercise, I'm going to use a sensor that comes by default as a normally open. So that only when we are connecting it, it can. Okay, so go on the side profile to see where is it positioned. Right? It's not positioned in the right place. Let's put it there. Then V. So I'm going to ask you a very simple question. Is this presentable for a sensor to sit like this on the conveyor belt? It's not presentable. So we introduce brackets now in order to lift the sensor. So I'm going to place a bracket. Let's look for a bracket here. Here's it, the angle bracket. Take the angle bracket and place it somewhere there. So now, as you can look at the bracket, it's not facing the direction I appreciate. You can right click on the bracket and turn it around. Then, so that you can now place it nicely somewhere there. Press V. Then now it's seated nicely there. So, but I want it to sit on the side like this. Then now our sensor can now sit on top of the bracket. You see now, our sensor is sitting on top of what? A bracket. So now if we go under drive, you will see that our sensor is diffuser 1. We place it there. It is a normally open, meaning that it's not connected currently. It's not a normally closed, which is normally connected. It's a normally open. All right? So now the sensor is ready. Let's now amend our program to include the sensor. I'm going to click on stop there. Copy and paste. This one is I2. Change this one here to I2. Then this is a sensor. Its location is at point A. Point A. If you want, you can just say sensor at point A, but we don't need to. Point A, I can always see what you're trying to say to me. So now, because it comes as a normally open, if we place it as a normally open there, it will never function the purpose of stopping. Let me show you that, what I mean by that. So now you see this I2 it's disconnected. So in other words, in order for it to connect, the crate needs to be at I2, and in which in this case we want to move to I2 and only disconnect when we're at I2. So we're going to set it as a normally closed here. We're going to right click and go to negation. So now it is a normally closed. Then we click like that. And now you see it is blue now. They are both blue. It means that when the current comes, you will find this connected in series and it will allow for perfect flow of current to Q0. So now let's then start the machine. Press play. Zoom nicely, get a perfect angle, and press start. So now the machine is moving. If I press the stop button, it will stop eventually. Now I just want to show you what is happening here. I press start, then it's running. I press stop, then it stops. I press start. Look what will happen when it reaches I2. Now it's at I2, it has stopped running. So we do that on this, stop and start. Now I'm going to start this, and then I go around just to so that you can see the sensor in action. Now the sensor is active, and the beauty about this sensor, it has an indication light there. If I remove this, you see, and it has an indication light to show that it's now connected. So now I want to show you also another stand. When you press sensor tags, you can see the state of your inputs. Let's see if I also do this. Now you can see that we have a belt conveyor by just clicking on this stuff there, right? So now let's press stop. Now all our labels are there. The diffuser, when the diffuser is white like this, it means that it's not connected. But our stop button is it's it's yellow. It means that it's connected, right? So when I press it, it becomes white. You see that? When I let go, it becomes yellow again. Then when I press start and hold the start button, you see what is happening. And then look at your conveyor belt, it's yellow there. And let's see what will happen with the diffuser sensor. Well, you see now when it's active, it becomes yellow. This is how you trace that you are having signal, right? So this is what I wanted to show you guys. This is what was supposed to have happened in the lab. So going forward, I am going to make this to be a little bit complicated. I will add more stations. For instance, I can say, for instance, when it reaches here, I want it to go forward. Or we can put a condition to say before it can move, it really needs to be at position, maybe position A. So let's make that condition now. Let's put it on the side and take the sensor there, right? And combine them, group, move it to this position. Oh, we don't move. Mhm. Uh, okay, and you stick maybe there, yes. Then orbit will do this nicely. But not winning, let's orbit again this way. Go forward, orbit this one, go up, go side. So yeah, I think it is placed nicely. So now this we can just copy paste. Is now we're having sensor 2. Now we're going to take the sensor 2 to that area then. Now we have multiple sensors. You see that? Just like that, we have more sensors now in our system. Then we take our box, we place it nicely there. So we can put a condition to say, in order for this system to run, sensor 1 needs to be active, right? So let's then add a sensor under the drivers. We will just add sensor 2. Okay? And we come here, stop, point A, copy, and I3 is point B. I must make sure it matches what is happening here. So yeah, it's at number 3 there, the last one. So now this changes to 3, 3 point B, right? So the condition is that this must never run unless there is a crate in this location. Okay, so obviously, in order to demonstrate this one perfectly, we need to remove the crate and see what will happen. We can just say start. Now it will fall there. Then let's put our condition in our program. Over here, we put our input like this as I2. And then this one's going to be I3 because it's sensor at number 3. And if you can look at here carefully, point B, which is I2, is the one that is at A now. So we changed that. So this one becomes I3, just like that. So now install program. Okay, now let's see. We go up. When I press, this doesn't run. Let me show you. I press, you see, we need a condition at I2 to be active in order for the whole circuit to be complete. Okay, and now I bring my product now. I can't really bring it there. So let me put it now there, and then I start. So now it's there. You see that I1 point A sensor is it's now active. Okay. Now if I press this, it will now run. Did you see that? Then it will run until it reaches the sensor B there. So how does this look like on the program? Stop here and start. You see I2 is active. Then I press start. Then it will run until it reaches I3 and it will break the circuit at I3. So this is the end of our intro to Codesys. So any problems I can encourage you to download the softwares into your PCs, install them, and practice at home. When you experience any issues, please let me know. I'm going to teach you several techniques. Then after that, I will test you based on those techniques. All right? So let me not make this video long and end my session here. Thank you so much. We will continue next week, Thursday.